Hello everybody, I'm Kent Mayhew and this is New Thermodynamics on YouTube, and I've also got our website www.newthermodynamics.com. Today we're going to discuss Gibbs free energy, a new perspective based upon logic. I previously discussed why Gibbs free energy was illogically mathematically obtained, and on a video called Differential Shuffle. So you may want to look at that before you go to this one. Now, too often we get things right for the wrong reasons, okay? And in the sciences, this is what philosophers call confirmation bias. And confirmation bias is a cognitive bias that involves favoring information that confirms your previously existing beliefs. It's human nature. It doesn't matter whether you're talking religion, government, science, whatever. Okay, it's just the nature of humans. We jump all over that which seems to emphasize what we previously believed. Differential shuffle and the resulting Gibbs free energy are prime examples where an illogical theory is applied that seemingly explains empirical findings. Okay, so we're going to examine this. At the risk of being repetitive, I must emphasize that this is a continuation. This slide was presented in other videos, but basically lost work is work that is lost irreversibly onto the surrounding atmosphere by expanding systems, and it is defined by work lost equals PDV atmosphere. Please see my other videos for more information on this. And at the risk of repetition, I want to emphasize the atmosphere cannot do work onto a system that is at one pressure atmosphere. This has been discussed before in other videos, so we'll just go quickly through this one, okay? Let us now consider an endothermic reaction, okay? So there's a gaseous endothermic reaction with both the temperature and pressure decrease, as is shown in figure 1411. Okay, so du is greater than 0, du being the change in bonding energy. dt is less than 0, dt being the temperature change or drop, and dp is less than 0, that being the pressure drop. Okay, based upon this, we can write that the energy change of the system is ncv/dt, and it is equal to du minus vdp. Okay, this will make sense in the next video or the next page. Continuing with the emphasis, so du is the change associated with the chemical bondings, and vdp is the energy associated with the natural pressure temperature relationship. You got to remember that in my papers on kinetic theory, we have shown that intermolecular collisions do not need to be elastic, and inelastic collisions make a lot more sense. We see it on all scales, okay? So it makes no sense that thermodynamics is written around elastic collisions. All collisions are inelastic, and an inelastic collision means that a photon or heat is given off with every collision, okay? So as the pressure changes in a system, so does the temperature related to that pressure, okay? And N times CV, and CV being the molar isometric heat capacity, times dT is the system's thermal energy change. Okay. So we begin again with that first equation, right? So the chemical change, du, minus the pressure change, isometric pressure change, is going to be equal to what we read as the thermal energy change. Okay, so the amount of energy that one could extract from this system, called G extraction, where we're using G because that's what there's traditionally used as Gibbs, would be equal to the following relation. Okay, and that is based upon the above. Now take a look at the traditional writing of the Gibbs-Durhem relation. Okay, again, it's written in terms of entropy times temperature change, or SDT. And this actually corresponds, if you think about it, to the thermal energy change of the system. The two equations are fundamentally the same, okay? Gibbs-Durhem relation was obtained via that differential shuffle, which I discussed in another video called Differential Shuffle, and how outrageous it is the way it's derived, okay? Now we can see that we derived a similar equation by first principles. So which one is right? In the slide before, okay, in other videos, the point is experimental data can only disprove a theory. It can never actually prove a theory because more than one theory can explain given findings. Now, I've shown you how to obtain Gibbs free energy by simple deduction, right? You can either accept that, or you can go on to what I call the outrageous differential shuffle, where differentials are shuffled around and there's no logic behind it. Okay, and please see my video on differential shuffle if you don't know what I'm talking about. So again, when two theories claim an experiment as proof, logic dictates that the simpler theory is more often the better theory. Again, here on this video, I think that we have shown that Gibbs free energy can be explained in much simpler terms than what is accepted. And I end the slideshow with discussing my book, New Thermodynamics, Say No to Entropy. I want to express that I'm rewriting it for the third time, namely because I've had some new insights, okay, and the new book will probably be called New Thermodynamics, Goodbye to the Second Law. The realizations have changed things like Chapter 4, so I'm sorry if anyone bought it. You can get Chapter 4 online from my website, www.newthermodynamics.com. Most of what I've discussed here is in my books and in my website. Okay, also on my website you'll find my peer-reviewed and other papers. I do apologize for my odd mistake, as they certainly exist, and I guess I'm really apologizing for being a human being. Okay, accordingly, any help and or improvements or commentary is always appreciated.